Hello students, in this video we are going to understand the applications of binomial distribution in an example. Now I have selected or chosen question number 5.646 given in the book. According to daily racing form, the probability is approximately 0.67 that the favorite in a horse race will finish in the money, that is first, second or third place, that is that particular horse win the prize. In the next five races, what is the probability that the favorite finishes in the money? In part A exactly twice, in part B exactly four times, in part C at least four times, in part D between two and four times inclusive, in part E determine the probability distribution of the random variable X, the number of times the favorite finishes in the money in the next five races. So over here we can identify that we are given n value as 5. Okay, so n is given as 5, whereas p is given as no 0.67. So what we do, we list all possible values of x. So why I'm working directly on part E, because it helps us to answer all remaining parts in an easier manner if we directly construct the probability distribution at the first place. So over here we start with 0, then we have 1, then we have 2, then we have 3, then we have 4, and then we have 5. Now 5C0, 0.67 to the power 0, and 0.33 to the power 5 minus 0, according to formula of binomial distribution, which is to estimate probability using binomial distribution. We are supposed to use this formula. So then we have 5C1, no 0.67 to the power 1, 0.33 to the power 5 minus 1, that is 4. 5C2, then no 0.67 to the power 2, then 0.33 to the power 5 minus 2. Then this is 5C3, 0.67 to the power 3, 0.33 to the power 5 minus 3. Then 5C4 we have no 0.67 to the power 4 and no 0.33 to the power 5 minus 4. And then 5C5, no 0.67 to the power 5, 0.33 to the power 5 minus 5. So now the probability are 5C0 is 1. So 0.67 to the power 0 is also 1. So this is just 0.33 raised to the power 5 we need to work out. And that's 0.0039. So we round off the probabilities up to 4 decimal places very carefully so that it gives us a sum of 1 when we add all the probabilities. Now the next value is 5C1 is 5 multiplied by 0.67 and multiply this by 0.33 to the power 4. That's 0.0397. Now the next value 5C2 is 10. So 10 times 0.67 squared and multiplied by 0.33 to the power 3. Now the probability is 0.1613. 5C3 is also 10. So 10 times 0.67 to the power 3 and multiply this by 0.33 squared. That's 0.3275. 5C4 is 5. 5 times 0.67 raised to the power 4, then multiplied by 0.33 gives you the probability of 0.33249 it is giving us, so we can round it off to 0.3325. Now the last probability is 5C5. 5C5 is 1 times 0.67 to the power 5 is the only thing we need to work out. So 0.1350 is the probability. Now check whether we are getting the sum of 1 when we add them all. So 0.135 plus 0.3325 plus 0.3275 plus 0.1613 plus 0.0397 and plus 0.0039. That's making 0.9999. So what we can do, we can make the very first probability change to 0.0040 because that's the highest number we can observe at the third decimal place. So this can be rounded off to 0.40040 and that will ultimately give you the sum of 1. Now what we are asked for in part A, so part A can be answered as, first of all, it can be written as probability of x is equal to 2 because exactly twice it is asking for. And what we can do, we can just select this answer because we have worked out already. So the probability or the chance, probability is 0.1613 and the chance is 16.13%. Now part B can be answered exactly 4 times, so we need to select this probability of 0.3325 to answer this part B. Then to answer part C at least 4 times, that is 4 or more. So at least 4 means x is greater than or equal to 4, which is probability of x equals to 4 plus probability of x equals to 5. So that's 0.3325 plus 0.1350 will give you the answer, and that is 0.4675. Now part D is asking us to work out the probability between 2 and 4 inclusive. So when we write down between 2 and 4 inclusive, this is how we can write it down. And it will include probability of x equals to 2 because equality sign is given just because of using the word inclusive. Then probability of x equals 3 and then plus probability of x equals 4. So we need to add these three probabilities, 2, 3 and 4. So 0.1613 plus 0.3275 and plus 0.3325 So that's 0.1613 plus 0.3275 and plus 0.3325 gives us 0.8213 as the answer. Okay. What if we are given the words in part D instead between 2 and 4 times inclusive? If inclusive word is not provided, then between 2 and 4 we will choose 3 only, the probability of 3. That is 0.3275 will be the answer in that case. And as we have discussed, or as we have already constructed the entire probability distribution, so part D we have done already in the beginning, so that we can answer each and every question in an easier way or quicker way. Then identify the probability distribution as right skewed, symmetric, or left skewed. So it depends upon the probability value. We have discussed. If the value is above zero point 0.5, we expect binomial distribution to follow the shape of negatively skewed distribution. And it is slightly negatively skewed distribution we observe because this is not a value very close to 1. It is a value close to zero point 0.5. So 0.67 gives us a probability of p-value, in fact, probability of success of 0.67 gives us the shape of the binomial distribution as slightly negatively skewed distribution. So that's all for this session. Because in part G, you can do it on your own. We have already I have already taught you how to construct or draw the graph of probability distribution or probability histogram in the previous lecture video. That's all for this video.